for solving DC circuit calculation questions. These are some of the tips that you can use when you come across a circuit diagram and you do not know how to start. Okay, so the first step, if we come across a circuit diagram and if the circuit is very complicated, you have resistors all over the place, the first step is always to redraw the entire circuit to simplify the circuit. So what do I mean by when we redraw it? We shall always have the battery only in the top branch and all the other resistors or components arranged in a single line at the bottom branch. Okay, later on I'll show you an example. What do I mean by that? Okay, then after we have redrawn the circuit, to simplify it already, in our head, we should mentally think about how does the current and potential difference flow in the circuit. So I will usually trace out how does the current flows out the battery, whether it flows in a series circuit or whether in a parallel circuit, where at which junction does the current splits up, which junction does the current join back, as well as how does the potential difference vary at different parts of the circuit. This one I will just think in my head mentally. Okay, then step number 3, if we do not know where exactly next thing we should start on, we look at the entire circuit, we find the region of the circuit where there is the most information given. Okay, so what do I mean by most information given? That means we usually want to find either the current, voltage, or resistance, these 3 things. Okay, at any one point, if there is any part of the circuit where 2 of them are known, okay, you can actually start your calculation from that section. Okay, next one, step number 4. So how do we start our calculation? We usually use the formula V equals to IR to solve the different parts. Remember, if you are using the voltage of the total voltage of the circuit, you need to use the total current flowing in the circuit as well as the total resistance of the circuit. If I'm only finding the voltage at a particular point or across a particular component, I only use the current at the point or the current through the component and the resistance of that component. Okay, so it's very particular about which areas of the circuit are you using for your VIR. But sometimes we realize that there is insufficient information. Okay, we cannot, there is only one item being known out of the VIR. So we cannot find the rest. So in such a case, when there is insufficient information, we go to step number 5. So sometimes we go to step number 5 and then we jump back to step number 3 and 4 to use the VIR formula. Okay, so what are the relationships in a series and parallel circuits? We have the first one, the current is the same in a series, but current will split up in a parallel circuit. The next one, voltage will be opposite of current. In a series, the voltage will be split up across the component, but in parallel, the voltage will be the same across all the branches. And then lastly, the resistance in series, you just add them up, R1 plus R2, you get the total resistance. But for resistors in parallel, you need to get the reciprocal. So it's 1 over RT equals to 1 over R1 plus 1 over R2. And you remember, you need to flip it. Okay, so remember for series, whenever you add more resistors to it, the total amount of resistance increase. But when you add resistors in parallel, the more you add, the lower the total resistance gets. Okay, so let's take a look at the following circuit. Okay, I am given this circuit over here. Okay, I am asked to calculate I1, I2, and I3. So the first step when I comes across this, I go back to my step number 1. I need to simplify this diagram. This diagram is too messy. I do not know which resistors are in series, which resistors are in parallel. So how do I simplify the diagram? Okay, I have already do the first step for you. I simplify the diagram. So the simplified circuit looks over here like this, where I have the battery only at the top branch, and I have all my other resistors, my 2 ohms, 5 ohms, 15 ohms, and 5 ohms, all the other resistors arranged in a single line at the bottom branch. Okay, so I usually use color codings to help me. Okay, to understand how does the current flows and things like that. So the first step, okay, I have a current flowing out of the battery. I use the blue line over here. Okay, so this current is flowing out of the battery. I reach this point where I split. So this is the same as here. So I have a current flowing out. Okay, then I go to the bottom before I split because I only want battery in the top branch. Okay, so at this point here, this dot here belongs to here. I will split up. So when I split up into path 1 with I1. And in path 1, I only have a 2 ohms ampere. So this is my path 1. Okay, I have I1 over here. Okay, and it only passes through the 2 ohm resistor. And I also split into a path 2, I2, where I pass by 5 and 15 ohms. So this is my path 2. Okay, from the dot, I split up into my pink line and my yellow line, 5 and 15 in my yellow line. And then after that, I will join back. These two paths will join back at this dot, which is over here. And then I will flow back into my battery, which is again the blue path. Okay, and before I flow back to my battery, I still have a 5 ohm resistor. So I still need to add it 5 ohms over here, which is the last part over here, 5 ohms, before I flow back to my battery. Remember, the top row or the top branch will only have the battery, while the bottom branch will have all the resistors arranged in a single line at the bottom. So this is how I simplified my diagram. And then I do all my labeling. So this is I1, I2, and I3. Okay, so after I've done with that, I do a mental note of how does the current flow. So the current flows out of the battery, then I'll split into this pink and yellow path, and then I'll join back to this 5 ohms. Then how does the voltage change? So the voltage will be 12 volts, 12 volts all the way until here. And then I will use up some voltage at these 2 ohms, and I will use up some voltage at these 5 and 15 ohms. Since the pink and the yellow branch are in parallel to each other, the voltage across the 2 ohms will be the same as the voltage across this 5 plus 15 ohms, 20 ohms. Okay, then this is not equivalent to 12 volts because this 12 volts, some of the energy will still need to be used up by this 5 ohm resistor. So maybe this side might take 8 volts and then this side might take 4 volts. Okay, so the sum of the pink and yellow, which is equivalent voltage plus the blue volts will give me my 12 volts. Okay, then this is my mental note. Then I move on into step number 3. I need to find out where do I start in the circuit. So let's take a look at all the information given. I have 12 volts, which is the total voltage. And I have all the resistance. 2 ohms, 5 ohms, 15 ohms, 5 ohms. So I have total resistance. I have total voltage. This is what I know. I know VT and RT. So I can start finding IT first because I have 2 knowns. I can find my third known. Okay, third unknown. So my IT, okay, is the current flowing through the whole circuit, which is also equivalent to I3. So I'm finding I3 first. So I'm going to apply the formula. Okay, step number 4, I'm going to apply the formula V equals to IR. So my RT first, I need to find the total resistance first. So this is top branch, pink branch is 2, bottom branch is 5 plus 15, 20. They are in parallel, so it's 1 over 2 plus 1 over 20, you flip it. Okay, and then after that, I still have one more 5 in series, so plus 5. So this is my total resistance. Then I want to find my total current, which is also equals to I3. I use V over R. So it's 12 divided by total resistance, 6.82. I get 1.76 ampere. So this is my current I3, which is also the total current. Okay, so next I'm done with I3. I need to find I1 and I2 now. Okay, so we move on to the next step. In order to find I1, I need to have the voltage here across the pink one divided by the resistance here. I have the resistance, but I do not have the voltage. Okay, and in order to find I2, similarly, I need the voltage across this yellow branch, which is the same as the pink branch, divided by the total resistance here, which is 20 ohms. But again, I have insufficient information. I don't have I don't have V. So I could not move on. Okay, in step number 4, using VIR. So I need to move on to use my relationship. Okay, so in my relationship, I know that pink and yellow branch are in parallel, so the voltage is the same. And then the pink and yellow, okay, together with the blue, they are in series together with this blue one. So the voltage, 12 volts, is split between this part and the blue part. Okay, 12 volts is split between them. So whatever I can do next, I think where do I have all my information? I have I3, which is the current flowing through the 5 ohm. I also have 5 ohm, so I'm going to work on this blue section first. Okay, I have the resistance, I have the current, I can find the voltage. So the next step, I'm going to use the voltage of the 5 ohms, which is the current here, 1.76 times the resistance here, 5, I get 8.8 volts. So with here being 8.8 volts, I can use the relationship to find the voltage across this pink and yellow one. So the voltage across the pink will be equals to the voltage across the yellow because they're in parallel, will be equals to 12 volts minus away this 8.8. I'll be left with 3.2 volts. So across this pink, it will be 3.2. Across this yellow, it will also be 3.2 volts. And now with the voltage, with the resistance, I can find the current. So I move back to step number 3 to apply VIR. So I1 equals to the pink voltage divided by 2. Okay, so it's 3.2 over 2, 1.6 ampere. And then I2 will again be the same voltage, 3.2 divided by 20. I get 0.16 ampere. So this is how I solve a circuit questions.